Gatekeeper here, just finishing up this 2 driving 6, 2 HG MRF 454s. Anyway, getting the I just got done getting the 2-pill section tuned out, and anyway, after I've got a leader line in here to get it tuned, and I was just going to do a quick video clip just so you can see what the 2-pill section is doing with the bench radio, because this is not a staged box, so you won't be able to see this after this point. So this is the 2-pill section. Got a leader line hooked up, so it's going in the 2-pill, out the 2-pill, directly to the bird meter. So it's coming in the amp, as you can see. It's coming in the amp, hitting the RF sensing circuit, aka keying circuit, and going through the variable, through the 2 HG MRF 454s, out the leader line to the bird. Oh yeah, right there, about 200 watts PEP. Oh, a little bit over 100 bird. That should drive these 6 pills pretty decently, especially once it's hit with a hot radio. I think it's going to do pretty good. We'll see. All right, let's get the 6-pill section tuned out. Alrighty. Got a little small issue with the combiner that I originally had on there. Basically, this was the last of its kind that I had made quite a few years ago. This is RF part 43 core. This is what they released as 43. And as you can see, just the physical appearance of both of these cores are completely different appearance-wise. This 43 is very, very shiny, and this is not. This looks just like 61, but if this isn't 43, it is a higher permeability type core, but it wasn't working with this. There wasn't enough isolation between the ports. And the way that I could tell that was, y'all ready for this? During a good audio, there was no warmth hardly at all between the 3 balancing resistors. They're not technically balancing anything, but the balancing indicating unbalanced resistors. I had some cool name for them a while ago. Actually, I wrote it down. Well, it's over there up under that. But anyway, their telltale resistors let you know if there's something wrong with any of the sections. But anyway, when you was on a good audio, a good steady wouldn't hardly feel any warmth coming from these at all. But with a simple dead key, now we're talking about 1 watt dead key coming from the radio straight into the 6-pill section, you would begin to smell these things getting close to start smoking. That was due to not enough isolation between each port. So you got to have a certain amount of isolation, which is measured by decibels, from each of these ports for this design to work. I'm not going to get deep into all that, but it was literally my last thing that I really truly had to learn about this style of amplifier. And you can continue with this style with many other types of styles. 2 6s, combining 2 6s together, ported like this right here. 4-pill ported. I'm gonna do one of them here soon, a 4-pill port. That's a pretty fun build to do. It's just another way to skin, like I say, there's many ways to skin a cat, or there's many ways to pull an orange. Well, there's many ways to build these amplifiers and get the output out of them. Some of them are more efficient, some of them are easier to do, some of them take less time. But it's just fun experimenting every once in a while. But I love this design 6-pill. And as you'll see, I still have 61 on the input, and that always works. You can use 61 or a higher permeability core. So this right here is kind of breaking history for me when it comes to builds. This is the first complete all metal clad 6-pill. It's a 2x6, but 6-pill final amplifier. And what I mean by that, you'll see me do an 8 or something, and I'll still say all metal clads. Well, that's talking about all metal clads where you can physically put them without frying the dang things, like on the outputs. Well, the problem was, these are my doorknobs. This was the last 150 picofarad Russian doorknob I had. And these are, it says 10%, but a little bit more than 10% variance one way or another. I had two little issues. I didn't have enough room to put this in here for one thing. I was going to have to mount it on the back. The next issue I had was this was about 15 picofarad higher than it needed to be, which wasn't a huge issue. But when I got to sitting down there thinking, this was my logic, okay? Let me stop moving this camera. I'm so bad about. Take a hit of this old Kato bar real quick while I'm sitting here pondering. Here was my logic. Y'all follow me down memory lane. All right. If you take a look at a Texas Star 667 or 500, they have one 500 volt metal clad 100 picofarad capacitor on the output combiner. I mean, I have repaired a lot of Texas Stars. I don't think I've ever had to replace one of them. I've had to add them a lot to the older style, but I don't think I've actually had to replace one from one below him. If I did, it was I can't remember. So that holds up just a single 100 picofarad on a 5-pill, 4-pill Texas Star. And yeah, of course, that amp doesn't do as much output as one of these style amplifiers do. Yes. Okay. Let's go over to a Texas Star Sweet 16. On the Texas Star Sweet 16, they convert it over to a 1,000 volt part by using 225 picofarad capacitors, 2 in parallel and then 1 in series with that parallel to ground, which equals a 1,000 volt part, which is what you see me doing right here. What this right here is a 1,000 and a 180 in series, which equals right there around 150, 152, 153 picofarad. So this is a 1,000 volt part at 150 something odd picofarad worth of capacitance. Now, if this will hold up on the Texas Star Sweet 16, I don't see any reason why this wouldn't hold up on the 6-pill. Now, the only reason I hadn't done this in the past with 6-pills is because I've always, in my mind, I'm like, hell, I got a doorknob right here, might as well use it. Or I got 2 high voltage ceramics right here, put them in series, I might as well use it. And I even talked to old Mudduck about this, and he said, no man, I don't want them high voltage ceramics in there. So I would have had to put 2 in series and put them right here in front of the relay. No, I don't want that. So he's one of them guys, he's got to have his amp exactly the way he wants it. That's just him. So we're doing this. We're going to try this and see how it works. I think he'll never have an issue out of it. And I may, from this point on, all my all metal clad version 6 transistor amps will do this way from here on out. So just wanted to share that. This is kind of breaking history in the old GK history books, the first true all metal clad 6. So all right, here's what we're going with for reflect on the input. After fine tuning it, I added one more capacitor to it it wasn't bad. If you see, this is a 5-watt slug. The 10 is 1 watt. In between that is half a watt. It was going up to the 3rd bar, the 3rd notch, and swinging back. So that's what you want with a tune. And once I added that little bit of extra capacitance, now it's only coming up to about the 2nd bar. But you see, oh, it's still swinging back. Oh. And whenever you can get that like that done that way to where it's falling more into resonance, the more drive you get it, that's what you're looking for. This is just a 500 watt slug in peak. Oh, and if I can get a 6 pill to do that on the peak meter, she's ready to go. RMS 1000, oh, about 140, 150. So, we've got the 2 pill section tuned out. We got the 6 pill section tuned out. Now it is time to connect them both together. And the way this is laid out, there's no better way to do this than to literally just take a wire and come across there. That's why I put this splitter right where it's at, so I could have a straight shot from here to here. And I do have some solid core 16 gauge or 18 gauge that I'm thinking about using, to where basically it'll be kind of lifted up just a little bit and then make a straight shot, just like a bar. But this right here is kind of in the way of doing that. I'll have to push it over a little bit, but that's about the best way you can do it. I mean, of course, you can use you can use a piece of coax to do this. Of course, you would just have to shoot it straight through there. You know, coax would probably be the better thing to do. So we'll see. I may use coax, I may just use a piece of wire. But the only other way to make this different would be to flip the driver section, which I've done in the past. And each way you do something brings forth new obstacles to get around, because if you flip this, now how are you going to get the power to the output section? You see what I'm saying? Since the bus is on this end. In the past, I've actually took that wire up under the heat sink. And when you do that, you've got to do a bit of work to make sure that wire, there's no possible way that wire will ever chafe that heat sink, will ever possibly, the insulation will ever be broken open. It takes a little bit of planning and work to run power under heat sinks like that. And I've done it a lot. I've gotten pretty decent at doing it. I've done it so much. So, but I think this was a little bit better. You got more pros than cons doing it this way, because the only con doing it this way is having to go across like that. That's the only con. So I'll mitigate my ways of doing that and pick one. I think coax is probably the best way, but we'll see. All right, let's put this thing together and see what she's going to do. This may be the first 454 driving 6 HT2879s that I have personally seen. I'm not saying it hasn't been done, but has it been done in the port style? Shout out to Mr. Stickman. We'll be back. Alrighty. Went ahead and went with the coax, as you can see, to connect both sections together. And went to test it, key up everything, and I noticed something very quickly. And this was just on the medium tap of the 100 amp transformer, okay? Which we're talking about only probably about 50, 60 amps capability. And you know this, what this box could pull, a lot more than that. I turned my dead carrier on my radio down to 1 watt, okay? 1 watt. That 1 watt was turning into 600 watts of carrier. You talking about an increase going from 1 to 600. it shocked me when I seen it. I mean, it literally shocked me. I'm like, wow. I'm like, we've got ourselves a little problem here. Because at that point, just where I was at, I wasn't even about to key or try to audio into that. So these 454s are a bit strong for these. I think it's I don't think, I know it's too much it's overkill. Two 454s really is too much drive for a setup like this. I pretty much saw that very quickly. So what I had to do is I noticed when I started turning the variable down to get to about 150 watt dead key, whereas it's a very good start for a 6-pill. Get your carrier around 150 watts, you know, get there around 150, 160, 175, somewhere around there. And by the time I did that, it was about there, which I knew it's probably sitting about 40 ohms or so. So I went ahead and put a 47 ohm resistor just to test. You know, it's not in there pretty, just to test. And that pretty much yielded this right here of a carrier. It's a 100 watt slug. 1,000 watt slug. Bottom scale, 20 is 200. Still a little high, I know. But at least you've got it to where you can now turn it down. But this is on the high tap now, okay? On the low tap, see, when you do a dead key on the high tap, that's bringing us down to about 15 volts. All right, but on the medium tap, it was bringing us down to about 13 volts or so, and it was right there about 175 watts. And as you can see right now, it's about 300. So I'm probably going to add just a bit higher of a resistor on there. But if you turn the variable back just a little, well, I didn't do much, did it? Yeah, I don't like adjusting carriers on the key. That's pretty hard on the taper of the potentiometer. So that's right there, about 200 watts. So keep in mind, this power supply is not big enough for this, okay? This is only a 100 amp supply. But what that yields us now, we've got the 2500 watt slug. Keep in mind, this is the bench radio. This is only doing about 18 watts peak driving into this box with a 3 watts RMS, okay? So what that yields is, on peak, 2500 watt slug top scale, go a little bit over 1500 watts, or about 1550, go right there about 500 so RMS. 14 volts. So as you can see, just on the bench radio, not even hitting it with a hotter radio yet, we are already pulled this power supply beyond its duty cycle. What do I mean by beyond its duty cycle? Well, this power supply right here, I haven't showed the side of it in a while. Y'all have to forgive me. It is a bit dusty back here. Made by my buddy Real Deal, which I talked to him not too long ago. It's got a 100 amp linear iron core power supply in it, okay? The high tap is at 15.6 volts. I believe it's 15.6, 15.4. I got it wrote down somewhere. So what that means is, once the voltage is pulled below that point of 15.4 volts, you are now straining the transformer. You're now pulling it beyond what it's designed to give. And yes, it will continue to give you current as the voltage drops, but you're now pushing that transformer, what we like to call, beyond its duty cycle of what it's designed to do. Okay, so I'm already there just with the bench radio transformer. Sorry, I get all tongue-tied when I'm out here in my videos. You know how I am. My problem really is I'm thinking 2 or 3 sentences ahead. But in my last videos, all my past videos of a 6-pill, I then always go to my 200 amp supply, which is in this guy right here. I'm not going to be able to do that today because I have not well, I can do it, but I have not fixed my cables yet. I got an issue with my cables down here, and I have bought what I need to do. Well, I have purchased what I need to fix these cables. I just hadn't took the time to fix them yet. So what I'm going to do is actually cut that right there and replace it. And I just hadn't done it yet, so I hate to say it, but with this video, I'm probably not going to be able to show what this bad boy really can do on RMS because I don't have the supply to give it. But I'm about to hook up the hot radio, and we're about to push this this power supply even harder, which I shouldn't really even be doing. But linear transformers are forgiving. You can push them hard and not blow them up. You know, they're pretty forgiving. But we're already getting a little bit over 1,500 watts peak, which is right on the money. I'm talking about on the money. Whenever I do these 6-pill ported boxes, if it's a straight 6, I'm hooking the 214-46 driver up to them, and that is right where they're at. The majority of the time, they're at 1,500 to 1,800 watts. Usually they'll be about 1,500 on the bench. When I hook up the hot radio, they'll increase up to 1,800. That's about how they go every time. RMS wise, they're usually about 500 to 600 right now. Then when I hook up the hot radio, then you'll see 8 to $1,000 usually. But that's on an adequate supply, so we are not going to see that today. But I'm tempted just to go down there and cut them wires, man, because I hate my lack of doing modifications when I need to do them, with me not being able to show an amp what it really truly can do. Even though I know everybody, most of my viewers out there trust me, what I'm saying is so that the amp is done correctly, and it will do that much if you drive it harder, but I still like to show it. But this is the first time me putting together an amp in this style of case, and I'm not going to lie to you, I like it. This actually came together real smooth. It actually came together a lot smoother than I thought it would. And see, this goes back to another question, going back to the input circuit. How do you know when it's time to add attenuation to an input of a circuit? Here's my method, what I use, okay? All right, the 1 watt dead key method. Most people do run a little bit more than 1 watt. You're pretty much going to mainly see 1 to 3 watt carrier range that people run their amplifiers at. 4 watts is pretty steep. Most people aren't going to be doing that unless they're running a high drive amplifier or something like that. But we're talking about amplifiers with drivers in them. You're going to usually see the 1 to 3 watt area. Most commonly the 1 to 2 watt area from the radio. Okay? If I key 1 watt into an amplifier and it is a lot higher than 25 watt carrier per transistor, so we're looking at 25, 50, 25, 50, that's 100, 25, 50, that's 150. If I'm putting 1 watt in it and it's going beyond that 150, just right there with the variable turned all the way up, then we know it's time to put an attenuation in, because it's already past that with just 1 watt. What's going to happen when the user puts 2 watts into it or 3 watts into it? They're going to blow this amplifier up. This thing's going to be having a very high dead key, and they're going to be swinging back, and they're going to be so oversaturating the transistors, and it's not going to last long. It's not going to last long. Let me put this, it's going to give a better chance of it not lasting long. So that's when you know it's time to add some attenuation. Now, with this right here, 47 still wasn't enough. I would like to see it doing around 100 to 150 watt dead key, putting around 1 watt into it. Because then I know when somebody puts 2 watts into it, yes, it's going to be a bit high, but then they can turn it down a little bit with this variable. That's why some people, what they'll do is they'll just go ahead and add a lot of attenuation to it and make it to where the user has to turn their carrier up, and it's kind of like a safety precaution. But then you got a problem with some people who run radios where they can't turn their carrier up, which I know most radios these days do have adjustments for it, but that is one little issue that people would come into, which I've seen over and over time again. Hey, I've got an amplifier, but it has no dead key, and I can't turn my carrier up on my radio. What do I do? Well, there ain't much they can do. They're going to have to do a modification to the radio or the amplifier one. So, but anyway, as it sits now, I'll add the extra attenuation once I'm done with all the dyno testing, as you can say. But you can also see too, it has a little preamp in it with invert circuit. And Mudduck, sorry, he really enjoyed the transistor I used in the last one. If you take a look at that little bitty booger, it's a tiny little bitty fellow, ain't it? That is actually the transistors that Texas Star used for many years. And I was able to acquire about 50 or 60 of them. And they're kind of unique because when I first attempted to use them, it didn't work. I know, y'all. I promise you, if y'all just hang in here with me, I'm going to get a stationary camera. Actually, the way that I'm going to get that stationary camera is I've found a nice website called cupofcoffee.com, and it's basically a donation website, kind of like Patreon. And I set me up an account because y'all got to know that those amp builders, we just don't make a lot of money doing what we do. You know, mainly the thing that keeps a lot of us going is we love what we do. If we didn't love what we do, we wouldn't be doing it all because we don't make enough money at it. For the last 11 years, I've mainly just made enough money to keep parts in here and to keep myself from not being out on the streets. But that you know, it's about it. I've definitely not made any extra yet. And at times, you know, I've had to sell a lot of stuff to keep going too, but we're still here rocking and rolling. But anyway, that actual transistor is kind of backwards. When you look at it, you have to hook it up backwards. The front of it, it's physically designed kind of funny. What you think is the front is actually the back. So once I figured that out by looking at the data sheet, I revisited the situation and used it. Actually, it was in his 2-drive and 8 box I did not too long ago, and it worked very well. So I'm gonna start using them again, and I can't wait to actually release the actual GK Pre. And actually, let's give a little sneak peek of that since I'm on the subject. This is the GK Pre. This is my test version. This thing will... There we go. It ain't focusing real well, but this is basically the very first one we put together. And I just keep it for myself as a test version. But this right here, I think, is going to change the community. As in the preamp community, people that love preamps, it's going to change the scene a little bit, because that preamp is very amazing. I don't even personally like preamps, honestly. I mean, I like them a little bit more since I've been working on that for the last 5-6 years, I guess. But that particular circuit, the GK Pre, is a very cool circuit. It can be put anywhere. It can be put in a radio. It can be put in an amplifier. It can be put by itself. It can be put down the line. I mean, if you're really wanting to get really the best preamp receiver, the results as possible, it can even be put right there at your antenna. See, some of the people who gets into the very low noise VHF type stuff, like meteor work, rain scatter, airplane scatter, bouncing their signals off, meteor trails and all that. They'll actually have a low noise amplifier, preamp, right there at the antenna. The preamp itself will be up on the pole at the antenna, and they'll have a switching circuit that switches back and forth with a T-bias going down the actual coax. They'll be actually sending DC signal down the coax to flip it on and off, because when you're up there like that on the VHF band, it can get hard to hear in certain situations, and having that actual preamp is the difference in night and day in making a contact. I learned about all that type of stuff, man, seeking the devices that I tried to use. I used a lot of different devices, and the one I settled with is the one I thought was best for the situation. But all right, when we come back, I'm sitting here just doing this right here, what us sea bears like to do. I'll be back. Let's hook the hot radio up and see if we don't smoke this supply. All right. Let's see what she's going to do. Right there about 600. Right there about the same. PEP. So there's no headroom in the PEP. That shows me right there we got a supply issue. So let's see what it's actually dropping to. Boom. 12.9 volts. Well, I wonder why it's only doing 600 bird. All right, a day later. I finally did what I should have done during the 2 driving 8 video. Not the last video, but the video I did a lot, not too long ago. But I should have done this then, so I could have showed that 2 driving 8 2879C box working the way it should. Could you put, son, calm down. I know Mama's home. This is one smart fella, okay? His mama just got home, and he knows it. How does he know it? That we still hadn't figured out, but he knows when she gets home. Maybe he hears her pulling up. I don't know. I don't see how he can where we're at. But anyway, so, yeah. Did away with these. Went with something a lot more trusting. Alright, so let's see what this bad boy's going to do where it's not being constricted any amperage that it needs. Alright. So with that amount of attenuation, 47 ohms, we're floating at 18.9. That yields us a little bit more 800 bird. About 1600 watts. About 900. Almost 900 bird. This 2 driving 6 is finished. Everything is good and cool. I'll tell you what, these 454s blow my mind how cool they stay when they really get to being hammered. Because of the attenuation, I could give it a little bit more dry. Would you calm down, please, sir? I'm going to go ahead and cut this video for now, y'all. We got a dog here wanting to, oh, the voltage drop. 15.5. A little high in volts. Not too bad. So wasn't able to show you 1,000 bird, but hey, we can't do that in every video, can we? But about, what was it, almost 1,600 watts. Oh, 1,600 PEP. Sorry for the camera movement. Let's see, 1,600 watts peak. With right there about 900 watts RMS, 15.5, and a nice dog here in the background crying. You can't beat it, y'all. We'll be back with the top on. I gotta figure out too if I'm gonna add a little bit more attenuation on here. We'll figure it all out. We'll be back with the final clip. Now she's got 2 cents she wants to put into it. Alrighty, y'all ready for another fan lid levitation? This lid is levitating. That's what you call back pressure. Right there. That lid is levitating right there. If I turn that off, the lid's going to fall. It just fell. So yeah, that is definitely some good airflow. No doubt about it. Alrighty. Got the fan mounted. Only thing I need to do now is put this down right here so I can tie strap this down so it's not going to be moving around. And I just want to give one quick view of the amplifier before we put the top on it, because basically you've only seen the amplifier from this angle pretty much. This would be a good short. Let's get it from this angle right here. We don't get this angle much because the amp's always facing the other way. Sorry, I don't know how that's looking. I'm just kind of holding the phone that direction. But anyway, we got the padding done. Went with a 47 ohm resistor with a 75 shunted to ground. So with a simple L attenuator. A little bit more than an L attenuator, but that's what we roll with. It's knocking it down to about 200 watt dead key. I would have liked to do it a little bit more, but I know he ain't gonna be happy with that. All right, let's get the top on, and we'll be done with this project and on to the next.
Show you this. This is a big.
All right.
I sent it to you this morning. It was in the tweets.
Thought I'd show it right here from this angle before I put the top
Twitter
on it.
Of the eugenics death cult. Talk about Nazis. I mean, we're gonna have.
Alrighty. Come together pretty good, man. Come together pretty good. I ain't even tested it on the preamp yet. I need to. Just hoping it's good. Trust me, if it ain't, we'll make it good pretty quick. Alright, I'm going to take a couple of pictures. I'm going to put the top on. Alright, here's where we're at right now. I was completely done with the amplifier, and the owner went and hooked it up, and he was having a issue with a 400 watt carrier with 2 watts, okay, and it was swinging great and everything, but the problem was the carrier's too high. So I'm like, all right, man, we'll do some attenuation to it, but I wasn't able to get to it in time. He had come over And while I was out, and I was actually talking him through some stuff, because I had 175 ohm right here to ground, okay, with a 47 in series. He said I told him, well, go ahead and take two 47s and put them together. You can tell that's what he did. That's where these are from right here. And he said, the dead key's still too high. And I was like, well, go down to 27. That's what he's got in here now. And he went and said, it's still too high. Well, I don't know what's going on, because look at this. This is just the way he left it, with the 27 to ground. When I was talking him through it, he was, yes, y'all. I know this guy that personal. He's a personal friend of mine. I do know him and trust him enough to be on my bench when I'm not here. I know it sounds kind of crazy, but I've known the guy for a long time. And, you know, he's old Mudduck. But anyway, something's going on here, because look, having this 27 to ground, this yields absolutely no dead key. Look at this. I'm keying. I don't want to key too much, because it ain't even pulling the supply down, but see? This is forward on the radio. 2 watts. What's a 5 watt load? And it's working too, because if I audio it, it's only doing like, what is that, 100 bird. So this is way too much attenuation. So I don't know what was going on when he was taking this out to his car and keying it up. I don't know what was going on that day. So what I'm gonna do is all I can do, me personally, is make this thing right here on the bench. So I'm gonna remove this this 27 ohm resistor and go back and try these, and I'll be back. So that yielded nothing. 2 watts down to absolutely nothing.